Swayam Prabha. Digital India. Educated India.
Good morning to all of you. Am I audible? So, I am Kannan. I am a retired professor from IIT Chennai and working as a senior professor at the School of Computer Science and Engineering, IIT Madras. So, I am going to talk about number theory mainly and the classical cryptographic algorithm. How many of you studied cryptography already? So, I will be handling mathematical part only mostly. So, even if you have studied cryptography also, you can reference your mathematics and few algorithms from cryptography also you know. Why we want to go for information security? Whenever you enter into the college, currently security. Why they are putting security is, they don't want to allow any intruders. So, inside web also, many people are intruding, they are trying to steal our valuable information. For example, they are stealing our bank password, then they can get our money. In this way, the hackers, intruders, they are trying to attack the information stored in the web. To avoid that, we have to prevent, we have to provide new mechanisms for prevention. Since whatever way we prevent, they will be finding a new method to enter into the information which we store. They may be copying, they may be destroying, they may be modifying, they may do any malicious activity. To avoid all these things, different techniques are available. I will be focusing on only one technique called cryptography. Why we need information security is, we have to maintain confidentiality. Whenever I set a question paper for my BTech or MTech students, I set the question, put in a cover, take print out, put in a cover, outside the cover I write confidential, then I hand over to the controller of examination. If controller of examination is not available also, if I am giving in the office, if I write confidential, nobody should open. It can be opened only by the controller of examination. Why it is confidential is, if confidentiality is not maintained, anybody can take one copy of the question paper. If the question paper is copied by many people, then there is no use of conducting an examination. That is why, first thing, whatever information you have to have confidentiality. In this era, whatever personal information or secret information with respect to bank or education, anything, if you don't keep confidentiality, then you will be the loser. Somebody will be writing the bank password in a notebook and keep. And somebody will be writing the computer password and write in front of the keyboard, keep it in front of the keyboard. Like that, if you are writing your password, secret information openly, you are going to be the loser. We have to keep securely. For that purpose, we have to maintain confidentiality. The people who are intercepting, they want to take a copy of that. You see the first diagram. In the first diagram, so the sender is sending the information. It is going, one copy is going to the receiver, another copy is received by intermediary. Intermediary is a malicious user. Let us say he wants to sell the question paper or something, whatever secret information we have, that he wants to take a copy. That is the first thing. Second type of fraud, what they can do is, they can modify. You are sending a birthday wish to somebody, or somebody is succeeding, getting first mark in the examination. You are congratulating them. You are sending a message on congratulations. But intermediate person, he is taking your message, he is modifying the message that, why did you get first mark? I curse you, you should not live forever, you should die in 2 days, like that. He will modify, and in your name, your friend will be receiving the message. So sender is sending a good message. The intermediate person, malicious user is changing it. After that, it is going to the receiver. This problem is called integrity problem. Integrity means who can modify, who should not be allowed to modify. So we should not allow modification of the message by any intermediate person. The sender should send it, and the receiver should receive in the same form in which we are sending. That is the second. Third, authentication or fabrication. Sometimes, when I was in Anna University, one outsider came on the first day of the semester. I allowed every student to enter into the lab. One man was coming with a fake ID card. He was also looking like wearing an ID card. But since I was taking the class for the second time, I know the students. I saw how a stranger is coming. He was not coming into the computer system. He was watching the bags of every student. Then I told the class rep, this student is not from your house, your class, I understand. You ask him who is. Then he told, I am a new joined, I came in second year, I am to this class only, like that he told. Then we inquired, after some time we found that he is a thief. When we found that he is a thief, I handed over to the dean and he handed over to the police. In this way, we were able to find out the person who was doing a fabrication or fake authentication. Authentication means whenever you go to the ATM, you have to authenticate you. How will you authenticate you as the correct person at the ATM? You have to give the correct card. First thing, if your card is fake, the ATM machine will not allow you. After that, you have to give PIN. This is the second thing. Even these two things are broken by the malicious users, the hackers. Therefore, now, for larger amount, if you are taking more than 10,000 rupees, they are asking for one-time password, OTP. So, these three mechanisms are used for authentication. So, authentication is very important in every place. When you come to the class, in VIT, in Anna University, no student will give fake attendance. But in VIT, it is a common thing that every student will, somebody is absent means somebody else will give the percentage. So, I used to be aware on the first day itself I will count the cat and count the number of people who are present. Second day onwards, I will try to remember the faces, and within 1 or 2 weeks I will try to say the names. Okay. In Anna University, I was not trying, but automatically it was coming. But in VIT, I try my best to remember the names. If you remember the name, then only fake attendance will not come. That part is fake authentication. Finally, non-repudiation. Non-repudiation means somebody send a message, but that message is disliked by many people. For example, it is against somebody or against a group, against the country. Like that, somebody is sending a message. Then, who is the sender? They will trace out and ask. He will say that I did not send the message. In my name, somebody else has sent. Like that, he will try to deny the message. That is called non-repudiation. You should not allow a person who is sending message to escape from denying. So he will try to deny. We have to say that you have sent it. These are all the 4 security goals. To maintain this, we have to go for different methods. Now I come to the technical part of my discussion. Cryptography. You are giving a plain text, for example, hello. Now you are using a key. Let us say it is adding 1 to every letter. H will be transferred to I, E to F, like that. If you are changing key equal to 1, then it will make a encrypted message, that is called ciphertext. Non-decryption means if you are adding 1, you have to subtract 1. Reverse process. then plain text will be received by the receiver. The term cryptography was coined from two words, cryptos and Greek words, hidden to write, secret writing. So it was made to conceal message from unauthorized persons. So it maintains secrecy, not only secrecy, it maintains privacy. You can write letters to your friends in encrypted form. It is maintaining privacy means only your friends will be able to decode the message. All the others will be looking like some junk letters is there. Since you have written some character, that character is changed to some other character, therefore it is not readable. People will think that it is some new language. Many languages will be having the same script. For example, like English, many other languages are also using the same script. But if you read, it will be looking like English, but it's not the same language. Similarly, in India also, Devanagari script, it is used in many languages. So, it is providing secrecy, not only secrecy, privacy. Then we can authenticate correctly. Next, it forms the basis to many security concerns. These are the terminologies. Plain text, it is a message which you want to send. Next, encryption, the process of converting the plain text to a ciphertext. Ciphertext is an encrypted message. Decryption is reverse of encryption. Key, with the key only we are doing the encryption. So plain text, ciphertext, cipher, key, encipher or encryption, T-cipher, cryptography, cryptanalysis. Cryptanalysis means just by checking it, you can understand what type of letters are coming. For example, you are writing a letter, maybe starting with the place and date. The date, if you are not encrypting, then they will understand that it is DATE. For D, you are using this. For A, you are using this. T, date, 34 letters with that, they can understand what is the key. Once you understand the key, anything can be decrypted. So that analysis is called cryptanalysis. And cryptology is the combination of cryptography and cryptanalysis. So some of the cryptographic algorithms are symmetric algorithm and asymmetric algorithm. In the symmetric algorithm, whatever key you are using for encryption, the same key you will be using for decryption. For example, Caesar cipher, I told you are adding, you are subtracting with the same key. That is symmetric key. But in the public key, you may be using something else. For example, x and y you are using. You are while encrypting g power x, then other person he will be doing power y, g power x power y. The difficult one key change we do like that only. For example, I know x, you know y. Both of us know g. I find g power x, you find g power y. I send you g power x, you will be raising the power to y, so g power xy. And you know y, I am giving g power x power y you are doing, g power xy. You are sending me g power y, I am having x, I am putting g power y whole power x, I am getting g power xy. But I am encrypting with g power x, you are encrypting with g power y. So we are using different keys, that is only public key. So the public key, the encryption key is different from the decryption key. The sender will be using a different key and the receiver will be using a different key. In symmetric key, both the sender and receiver both are using the same key. In the public key, the sender is using one key, sender's public key or private key, and the receiver will be, suppose I am using the public key, it will be known to everybody. So the receiver will be using a private key to encrypt. The classical cryptography, that is the simple cryptography, we have substitution and transposition. Substitution means you will be substituting A with B, B with C, C with D, that is a symbol substitution. Transposition means 1 goes to 2, 2 goes to 5, like that. Suppose first letter will be going to 5th position, second letter will be going to first position, third will be going to 10th position. So you will be doing like this. If I write the permutation in this way, one goes to 5, 2 goes to 6, 3 goes to 1, 4 goes to 2, like that. If I am having, let us say, if I write it like this, 1, 2, 3, 4, 5, 6, if I want to encrypt, 1 goes to 5, that means K will be coming to 5th place in that decryption. So it is coming to 5th place. 2 goes to 6, that means A comes here. 3 goes to 1, that means N will come here. Like this, if you are changing, that is only இது எப்படி பண்ணணும் தெரியுமா? அருண் இல்லையா? எப்படி சார்? சார் ப்ரெஸ் பண்ணிட்டே ரெஸ்ட் பண்ணுங்க. சரி. So this is the Caesar cryptography formula. Encryption of message E of M with a key K equal to C. Encrypted message will be called C, ciphertext, equal to M plus K mod 26. Decryption will be C minus K. Encryption is M plus K, message plus K. K will be 3 letters A. If you do like that, A will be converted to, suppose A equal to 1, B equal to 2, A plus 3 if you are doing, it will be D. Julius Caesar in his drama, how many of you know Shakespeare dramas? How many dramas are available by Shakespeare? 36 dramas are available. Okay. One such drama is Julius Caesar. In that, this sentence is coming, I came, I saw, I can go. In that language, in Latin language, it was vini vidi vici, like that it is written. In English it is, I came, I saw, I conquered. He succeeded, he was giving this message. But secretly he wanted to give. He was encrypting and sending the message. So when he was sending secretly, it was converted like this. I, after JK, it is L plus 3. Similarly, C, after DE, it is F. A, after BC, it is D. So, I came, I saw, I conquered, is encrypted to L, FDPH, L, VD set, like that it is converted. Now the plain text, everybody can read, but the cybertext is not intelligible, unintelligible. You want to convert to plain text. How will you convert the encrypted message to plain text again? Minus here. For this, the second formula is, you see the formula, it is minus. The first formula, it is plus. The second formula is just minus. Now, different types of attacker are there. The attacker knows the algorithm, but he will not know the key. Always you should think that the attacker knows the algorithm. The attacker knows the ciphertext. He wants to get the plain text. He does not know the key. If he knows the key and the algorithm, what can be done? Immediately decryption can be done. He does not know the key. He is trying to do some attack to know the key. One type of attack is called brute force attack. Brute force attack means trying all the combinations. Suppose you are forgetting your number in the number lock. How will you do the brute force attack? Start with 000, try to open. 001, try to open. Then 002, like that. If you are going on trying all the 999 combinations, you will be getting. That type of attack is called brute force attack. In Julius Caesar time, to do a brute force attack of a message written in a letter, it was taking years together. But now, after the arrival of computer, fraction of a second only it is taking. Therefore, Caesar cryptography is no longer useful after the arrival of computer, but this is giving an idea to change the plain text into ciphertext. He was giving the idea before 2000 years itself, many years before it, 2000 BC. So 2000 BC means before the arrival of Jesus Christ, 2000 years. So after the arrival of Jesus Christ, 2023 years are 2023 years are over now. But 2000 years before means Julius Caesar time is 4023 years. So that time itself he has found this cryptography. What he did is, he is doing a frequency analysis in English. Whatever letter, which letter is coming more number of times is E, then T, R. The frequency of occurrence of English letters in a paragraph or in a document, if you search, E is occurring more number of time. After that, T, this is the combination. Then digraph means two words. If you take, TH is appearing more number of time, he, in, like that. Trigraph, if you take the, and, these are all the most frequently occurring words. So, if you want to do cryptanalysis in English, for a plain text, it is looking like this. Which is having the highest one? E. If you see the first one, A, B, C, D, E is having the highest, tallest bar. But after after applying Caesar cryptography, E is not having the tallest one, which is having tallest bar. It is H. So it should be G. E means, sorry, H only, FG. E after FG, H. H is having the tallest bar. They understand that E is transferred to H. This is the method of doing analysis. This is called cryptanalysis. Now let me come to another cipher called Hill cipher. I told the Julius Caesar, Caesar cryptography was just addition. Addition is easy to decrypt using subtraction. But next cryptography was proposed by Hill. It was also before hundreds of years. He told that you have to use this method, C equal to Kp mod 26, where K is a matrix, P is a matrix, and C is a matrix. You see, multiply your plain text matrix with a key matrix. So you have to multiply the plain text matrix with a key matrix to get a cybertext matrix. So you see the formula, C equal to K into P mod 26. For decryption, you have to find the inverse matrix for K matrix. So matrix inversion will be difficult than subtraction. Subtraction is easy or matrix inversion is easy? Subtraction is easy. Matrix inversion will be somewhat tough. Therefore, so this is the formula. Suppose we are going to use view as plain text is view. You want to encrypt the text VIEW. View is for plain text. They start ABCD like this: A equal to 0, B equal to 1, Z equal to 25. Okay, they start like this: A equal to 0, B equal to 1, C equal to 2, D equal to 3, Z equal to X equal to 23, Y equal to 24, Z equal to 25, like that, starting from 0. Now view, V will be, it will be 20 first letter. Similarly, I, 8th letter. E, 4. You can verify this easily. E will be A is 0, B 1, C 2, D 3, E 4. So this E is written as 4. Similarly, W is written as 22. Now key we are taking as quickness. So if you write quickness in a 3 by 3 matrix, it is written like this. Now Q will be 16, U will be 20, I is 8, C is 2. This very easily you can verify. C equal to 2, easy to verify. All other letters you have to write and check. But you can check C equal to 2, K equal to 10, N equal to 13, E equal to 4, like this. We have taken a key. So we have a plain text matrix, we have a key matrix. Suppose the key is smaller, you have to repeat the key. For example, Ram, let us, key is Ram. You have to repeat Ram for 3 rows. Now, the complications are all matrices are not having a inverse. For example, the corresponding determinant is 0, the matrix will not have a inverse. So they assume that the matrix is having a inverse. Let us take an example. Attack we are going to encrypt. Under the table also they have given for easy reference. A is 0, B is 1, C equal to 2, like that one table is also given. We are going to take the plain text attack. We are going to encrypt. After encryption, they are showing the result as FK, MF, IO. We are going to get this. So how we are going to get? Here, mod 26 is very important. Okay. For example, W is coming. So which letter I will be putting? 22. W equal to 22. When W equal to 22, suppose we are adding 3, it's not a problem. Z let me take. Z 25. If you add 3, what will happen? 28. But 28 alphabets are not there. You have to use mod 26. 28 mod 26 is how much? 2. So it will be coming to 2. That way you have to. 2 means it will be C. Attack, we are splitting like this, AT, TA, CK. Three columns we are taking. The reason is we are going to make it as a 2 by 2 matrix, as the key they are giving us a 2 by 2 matrix. Since key is a 2 by 2 matrix, the word attack is divided into AT, TA, CK. So first we will encrypt the first one, AT. AT, A will be 0, T will be 19. Key is 2336, C equal to KP mod 26. You have to multiply the two matrices, key into plain text. If you multiply, you are getting 2 into 0 plus 3 into 19, 3 into 0, 6 into 19, mod 26, 57, 114, 57 mod 26 will be how much? How much is 57 mod 26? 2 times 26 is how much? 52. So 57 mod 26 will be how much? 5. 5 is which letter? F. F. So 5 is becoming F. Similarly 114 mod 26. 2 times 26 is 52. 4 times 26 is 52 plus 52. 52 plus 52 is 104. So 114 minus 104 is 10. This is the 10th letter. Okay. So we can see the table. Suppose whenever we have a problem in that, this k is 10. There itself 10. So I have converted the first one into fk. Similarly, the second one is converted to mf. Third one is IO. Overall, the ciphertext is fk, mf, IO. Are you able to understand all the three? Okay. So we have converted the plain text into ciphertext. Now we have to convert the ciphertext into plain text. We have to do inverse. For doing this, P equal to K inverse C mod 26. K inverse equal to 1 by determinant K into adjoint K. This is the formula. You know the matrix inverse formula. What is the inverse of a matrix? 1 by A, let us say matrix is A, 1 by determinant A into adjoint A. So determinant A, how will you find? The corresponding matrix you will be writing in determinant form. Just you have to cross multiply. If it is 2 by matrix, 2. So the matrix determinant equal to ABCD. You have to expand like AD minus BC, where D is not equal to 0. Now in this determinant is 2, 3, 3, 6. You know the key. Already you see this is the key. What is the key? First row is 2, 3. Second row is 3, 6. So the D equal to 2, 3, 3, 6. If you expand the determinant, what you are getting? 3. 12 minus 9 is 3. But it is not just 3. D equal to 3. You have to find 1 by 3. 1 by D. 1 by determinant A. 1 divided by determinant means D inverse. D inverse, how will you find this? In modulo pi algebra, I will tell you. After that, we will go to modulo 26 algebra. If you say A equal to pi, 1 by pi is the inverse in multiplication. Why 1 by pi is the inverse? When you multiply them, you have to get identity. Identity means with the identity, if you multiply anything, you get the same thing. That means the inverse in normal multiplication, the inverse of pi is 1 by pi. The inverse of 7 is 1 by 7. Like that we know. In modular algebra, let us say mod pi, what is the inverse of 2? 2 into something will give 1 mod pi. 2 into 2x mod pi equal to 1 mod pi. So what is x? 3. 2 into 3 is how much? 6. 6 mod pi is how much? 1. Therefore, the inverse of 2 is 3. Let me take modulo 7 algebra. Okay. In the modulo 7 algebra, what is the inverse of 2? 2 into something equal to 1 mod 7. If you take 2, 2 2s are 4, it is less than 7. If you take 3, 2 3s are 6, it is less than 7. If you take 4, 2 4s are 8. 8 is only correct. Therefore, the inverse of 2 is 4. This way you have to find the inverse. Here they are finding the inverse. You see the inverse. D equal to 3. D inverse is how much? 9. How it is 9? You see this line. 3 into 3 multiplied by 9 mod 26 equal to 27 mod 26 equal to 1. Therefore, D inverse equal to 9. When D equal to 3, D inverse equal to 9. Anybody could not understand this line? The inverse of 3 in modulo 26 algebra, it is 9. Anybody could not understand? Everybody is able to understand. If you don't understand, you start with 3 into 1 mod 26. It is less than 26. 3 2s are 6 mod 26. 6 is less than 26. Then 3 3s are 9. 9 is less than 26. 3 4s are 12. 12 is less than 26. 3 5s are, I am trying. 15, that is also less than notation.